On today's lesson, we're going to be talking about multiplication properties for exponents. Right here you see two like bases. Both of the bases here are x, and their exponents are 2 and 3. When you're multiplying those, you have to think of that as being x times x for x squared, being multiplied by x times x for x cubed. Now x here is multiplying itself 5 times, which would be your answer. Now keep in mind here that you could have actually shortcut this by thinking of it as being x to the 2 plus 3, where you add your exponents when like bases are being multiplied, which would have gotten you your answer. And that's what I'm going to be referencing throughout the rest of the lesson. Alright, for example 2, we have these two different problems. For this one, 2 is the base on all three, so you're just going to add all of the exponents, so they'll be to the 5th plus 2 plus 7 from the three different exponents being added here. 5 plus 2 plus 7 is 14, so 2 to the 14th. Now you stop right here and don't actually find what 2 to the 14th is because of the instructions that say rewrite each expression using each base only once. So you're not simplifying or evaluating here, you're just stopping right here. On part B, you're also going to add those exponents, negative 2 and 2, since both bases were 5, and you get 5 to the 0. Now I know that would be 1, but again, we're only writing it so where each base is once. Alright, on example 3, the only trick here is that this first base of x does have an exponent of 1 that people usually forget. So if you see a base and no exponent is written, it's an implied exponent of 1. So now you would know it would be x to the 1 plus 2 plus 4, and 1 plus 2 plus 4 sure enough gives us x to the 7th power. On the next problem, there are 4 bases here originally, 3 unique ones. So 2 is a base, it's to the first power. N is a base, it's to the 5th. 3 is a base, it's to the first power. N is a base, it's to the negative 2. You could rewrite this in a different order, where 2 and 3 will definitely be multiplying together, and so will the n to the 5th and the n to the negative 2 be multiplying together. Now, when bases multiply, they're constant values, you just go ahead and multiply those together like normal. So 2 times 3 is 6. And that will be n to the 5 plus negative 2, which will be 3. And that's done. Common error here is that people want to add the coefficients 2 and 3 together, but those still multiply. So follow your operation for your bases. Alright, on example 4, got another 2 problems. So one of my bases is c, so I'm going to go ahead and add those together. So c to the 4 plus 7 will be 11. For the d's, I'll do the same thing. So d is another base. Negative 3 plus negative 2 is negative 5. Now the reason why this one isn't done is it does say simplify, and it's never simplified if you have a negative exponent. So I'm going to have the c to the 11th on the numerator, and d to the 5th is going to go to the denominator, and that relates back to the previous lesson, which was day 1. Alright, on part B, I'm going to go ahead and multiply together the 3 coefficients, 5 times 2 times 3. 5 times 2 is 10, times 3 is 30. Now I'm going to multiply the bases of x together. This is x to the first, and x to the negative 8. That's going to make x to the negative 7, because 1 plus negative 8 is negative 7. And then y does not have anything to combine with, it's just going to say y to the 4th. Now I have 3 bases. 30 is to the first power, x is to the negative 7th, y is to the 4th. This is my problem right here, is that I need to move this base to the denominator so it will be positive. So I'm going to have 30y to the 4th on the numerator. I'm going to have x to the 7th on the denominator, and I know I'm done. For my last example, I'm simplifying this in scientific notation, so let's go ahead and see how that works. I would personally think of it as 7 is going to be multiplying 4, and 10 to the 2nd is going to be multiplying 10 to the 5th. So 7 times 4 is 28, and you'll have a times. 10 to the 2nd and 10 to the 5th will make 10 to the 7th by adding the 2 exponents together. Now this isn't really a good answer since it's not in scientific notation, so you want to make your first number something between 1 and 10. So I'm going to need to divide the 28 by 10 to make it 2.8. When I did that, I divided it by 10, so all of a sudden this extra 10 appears that's multiplying it, like so. And 10 to the 1st and 10 to the 7th is going to make 10 to the 8th power. So 2.8 times 10 to the 8th power. Now, If you're struggling with that, remember that a TI-83 or 84 calculator is going to be able to give you these answers, and it can be set into scientific notation with the mode key, and I can show that to you during tutoring. Please let me know if you have any questions. Thanks.